We mentioned that it's necessary to confirm the identity of the remote user. There's a special type of server providing such services. It's called the Radius server. In the RFC documents, this standard is labeled with the numbers 2138 and 2139. In the Microsoft environment, it's been implemented as the IAS or the NPS server. NPS, Network Policy Server, has been available from Windows Server 2008 onward. And IAS, Internet Authentication Service, can be found even in earlier versions of Windows. The Radius server is a central place that allows you to authenticate remote users and control their access. Remote users are defined as those who connect from outside the local network using, for example, VPNs. The Radius server controls remote access servers, RAS. Let's see how it all works. First, a user is trying to connect to a corporate network, that is to say, a remote access server, the RAS server. Then, the server, which is configured as a central Radius server client, will send the request forward on behalf of the user. The Radius server should be physically as close to the domain controller as possible. In the next step, the Radius will ask the domain controller if the user provided correct credentials, if the login and password or the certificate are correct. If the credentials match and the user has the right to log on to the remote server, the Radius server will inform the remote access server. Then it will ask the remote access server to create a virtual interface for the user. Eventually, a connection is established. There exist several ways to check credentials. First of them is the CHAP protocol. It is specified in the RFC documents 1994. This is one of the protocols which you should never use. For CHAP to work, you need a reversibly encrypted password. This protocol doesn't encrypt the channel, therefore the data is sent in clear text. The protocol has been modified by Microsoft and is called MS-CHAP. This version allows you to encrypt the data. To do this, it uses MPPE, Microsoft Point-to-Point Encryption. However, it does not protect against replay attacks or session capture. We don't use MS-CHAP either because it doesn't provide mutual authentication. Mutual authentication is available only in MS-CHAP version 2. This protocol allows you to store reversibly encrypted passwords. MS-CHAP version 2 is the least secure protocol among those that we should use in practice. In every possible case, and there are many, you should use the Extensible Authentication Protocol, EAP, in one of the available modes, for example, the TLS mode. At present, this is the only protocol that guarantees the security of the authentication data and the data sent through the channel established in this way. It also allows you to confirm the identity of a user or a host not only with a password, but with a public key certificate, a smart card. There are two more protocols that can be found on the lists of older network devices, RAS servers, and Windows systems. You should not, however, ever use them. These are the PAP protocol, which sends the password in clear text, and the later version of SPAP, which uses reversible password encryption. The latter can be broken by modern computers in real time, and when it comes to the former, there's nothing to be cracked. The last topic we'll discuss in this module is network access control. In corporate networks, there are more and more computers that are beyond direct control. These are not the demilitarized zone computers. These are users' laptops and mobile devices. Therefore, you have to take a different approach to subnetting. Do not group computers into subnets according to their IP addresses or their function. They should be grouped according to their security level. This is how the Network Access Protection, or NAP, works. NAP is a mechanism supposed to automatically verify the conformity of your computer with certain standards. For example, if the Internet Connection Firewall is enabled, whether the virus scanner is installed, and whether it is active, or if the operating system is updated, or if there exists a fixed list of tests that the computer must pass before it's connected to the network. Until the computer meets these requirements, it will be isolated. It will be automatically connected to a specific separate subnet. How can you create such a subnet? The first way is to use IPsec. Unless the client meets the security requirements, it will not be given a certificate, which can be used to communicate with IPsec. Without this certificate, the computer has access only to selected subnets. Such a separate subnet should consist of a remediation server and a server allowing to download and install missing updates. Another way to implement network access control is to use 802.1x protocol, which we have discussed earlier. You can enable or disable a switch port depending on whether the computer passed all the tests or not. You can also assign the computer to an appropriate VLAN. Network access control can also be implemented with the use of the DHCP server. A DHCP server with two address pools grants addresses from the pool A to computers that meet the policy's requirements, whereas to computers who don't, it grants addresses from pool B. Clients that connect remotely to our network can also be verified by the Radius server. The mechanism described, implemented in the way that's usually done in Windows, has one more important advantage. Rather than being carried out on a one-off basis during the connection, computer security tests are carried out regularly, over a period of time specified by the MPS policy. If someone turns off the firewall while connected to the corporate network, they will be immediately disconnected from the network, or the firewall will automatically be enabled by the NPS server. The technical implementation should proceed as follows. First, we need agents that will gather information about the computer's configuration. Also, there must exist a mechanism that will implement the method we've just discussed. We'll demonstrate how it will work on the safest mode possible. That is, the IPsec mode. First, connect the computer to the corporate network. In Windows systems, there's a security agent that assesses the security level of the computer. This service is installed along with the operating system. The service communicates with the quarantine server, the network's access control server, in order to check the rules currently in force. The agent evaluates the computer in terms of compliance with these rules in force and reports on the result of the evaluation to the MPS server. If the result is positive, the computer will be given a certificate. A certification authority issues a certificate that will be downloaded automatically. Certificates used in the network access control are short-lived certificates. Their default validity period is 10 hours. This means that the entire infrastructure associated with the certificate revocation and status checking is not needed. This is a very simple mechanism. If a computer fails the test, it will be redirected to a remediation server and, as a consequence, its security level will increase. It could involve, for example, installing missing patches. Likely, it will happen automatically and go unnoticed by the user. After the patches have been installed, the agent should assess the computer security status as consistent with the security policy. This means that it will be granted a certificate. Thanks to this, you will be able to use IPsec and get full access to the corporate network. The whole mechanism is not, strictly speaking, a solution for security, but it fits very well with current trends in computer system security. It eliminates the risks coming from neglectful users who, for communication with the network, use computers which have been connected to open public networks and which have run the programs from untrusted sources. The second part of this module has been devoted to the additional protocols and services that help secure the computer infrastructure. Thank you.